When 15 is appended to a list of integers, the mean is increased by 2. When 1 is appended to the enlarged list, the mean of the enlarged list is decreased by 1. How many integers were in the original list? So let's say that there is some sort of list of numbers, okay? And we don't know how many numbers are in here and what the numbers are. But we do know that when we append just means to add onto this from the sides. So when 15 is added onto the greater n of these integers, the mean increases by 2. And when 1 is added onto the smaller side, the mean is decreased by 1. And now we're trying to find how many integers were in the original list. So we can start by setting some variables. Let's let m is equal to the original mean. M is equal to the original mean. And let's let the other variable n equal the number of terms in the original list. And finally, since we have the mean and the number of terms, we know that the original sum of the numbers would just be them multiplied together, giving us the original sum. So we have essentially two variables, m and n, to help us write out our equivalent relationships. So let's start by writing the equations. Since we know that when 15 is added onto this list of integers, the mean increases by 2, we can write this by when the original sum, which is mn, is added by a 15, that is equal to the original mean plus 2, because the mean increases by 2, so m plus 2, times, and then we have one more number. So one more number is added to the original number of terms. So n increases by 1. Remember, n refers to the total number of terms. So that is our first equation. What is our second equation? Our second equation is mn plus 16. So mn, right, is the original sum. And we add 16 because we're adding 15 and then adding 1, because when 1 is appended to the enlarged list. So when 1 is added, the mean of the enlarged list, right, this is the enlarged list, this refers to the enlarged, is then decreased by 1. The mean is decreased by 1, which means that we are minusing 1 from m plus 2, which gives us m plus 1. And n refers to the number of terms in the original list. Now that we have added two more numbers, 1 and 15, the total number of terms has increased by 2 as well. So we have n plus 2. So these are our two equations. Based off of these two equations, we can then solve for n. So what we can do is subtract equation number 1 from equation number 2. Now this is just some plain old algebra that we need to start solving. So by subtracting equation number 1 from equation number 2, we get 1 is equal to mn plus 2m plus n plus 2 minus, in parentheses, and then we multiply these two parentheses together, we have mn plus m plus 2n plus 2. So now that we have this, we can start simplifying and combining like terms. So we can cancel out the two mn's, cancel out the 2's, and we are left with m minus n. So now we know that m is greater than n by 1. M is equal to n plus 1. And now that we know this, we can substitute it right into one of the previous equations. So let's say we substitute it back into equation number 1. This would give us n times n plus 1 plus 15 is equal to n plus 3 times n plus 1. Now we can continue multiplying these parentheses together and combining like terms. So on the left side we have n squared plus n plus 15 is equal to n squared plus n plus 3n plus 3. Now we combine like terms. So n squared on both sides cancels out, n cancels out on both sides, and we are left with 3n is equal to minus 3 on both sides, 12. So then n is equal to 4. And remember, 4 is equal to the total number of terms in the original list, which is also what the question is asking for. So there were 4 terms in the original list, and this is our final answer.